Hello everyone, it's Mr. Miller here. Hope that you're doing well. This is a recording of the June 2017 Higher Paper 3 from Edexcel. You can find the paper on Maths Genie, and before you look at any of this video, you should have spent at least 90 minutes doing the paper and then marking your work. And you can also find the mark scheme on Maths Genie. We're now going to go through the paper, so you should jump straight to the questions that you found difficult, or you can just watch all of the questions, really up to you. Let's start off with question 1 and see what we got. Okay, so it looks like I've got a Venn diagram, and I'm going to put some numbers into the Venn diagram, because I know that this funny little symbol here means the universal set, so I've got to put all odd numbers less than 30. Let's start off by just listing those odd numbers. So starting off with 1 and then 3, etc. It's always really helpful to list out your numbers so that you don't miss any out. I'm going to stop when I get to 29 because the next one is 31, which is more than 30. Okay, I'm going to put these numbers into the Venn diagram now, and usually it has an A and a B on here, but it doesn't here, so I need to write that in. So starting off with the number 1, well, it's not in A and it's not in B, so I'm going to put that on the outside. Let's put it there. And I can cross off 1 when I've done it to know that I can move on. And then let's look at 3. So 3 is in A, but not in B. So I'm going to put 3 here, cross it off. And then 5 is in B, but not in A. So I'm going to put 5 here. And not going to go through the rest of them. I'm just going to do it myself because it is the same principle. 9, 11, 13. Okay, 15 is in A and B, so 15 goes in the middle. Okay, that was pretty straightforward. Let's move on to part B. A number is chosen at random from the universal set. What is the probability that the number is in the set? You need to remember what this symbol means. That symbol means or, because it looks like a U, and that means or. So, okay, so probability. So I know that my answer has to be a fraction. So I'm going to draw in my fraction straight away. And in my denominator, I know it's the total number of numbers that I have. So let's count up the number I've got. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 goes in the denominator. And then how many are in A or B? Well, let's just get my highlighter out. I'm looking in the region A or B, so it is this whole region here. And I can see there's 1, 2, 3, 4, 5, 6, 7 numbers in there. So my numerator is 7. Nice and easy start. Let's keep going. Okay, next one, solve the simultaneous equation. So I've got 3x plus y equals minus 4, 3x minus 4y equals 6. So the first thing I'm looking at is to see if the coefficient of x or y is the same. If it's not the same, I'm going to need to multiply one or both of the equations. But I can see that my x's are the same. I've got 3x and 3x, so I don't need to multiply any of the equations. Okay, but now I need to decide whether I add or subtract. I know that I want to get rid of the x's, so I think I'm going to subtract here because 3x minus 3x equals 0. Now I need to be careful when I'm subtracting because I've got y minus 4y, which is y plus 4y, because when I take away a negative number, that is the same as adding. So that is 5y. And then minus 4 minus 6, well, you can put it in your calculator just in case, but it is negative 10. Now to find out what y is, divide by 5 on both sides, y equals minus 2. Next step, I need to find out what x is, so I'm going to substitute in y equals minus 2. I could do it into either equation, but it looks like the first equation is the easier one, so I'm just going to write that out again. So 3x plus y equals minus 4, and then I'm going to replace my y with minus 2. So that is 3x plus minus 2, so that is negative 2, or minus 2 equals minus 4, and I now need to solve this equation. So what's the inverse of minus 2? Well, it is plus 2. So I've got 3x equals minus 4 plus 2 is minus 2. And then I'm not going to worry that my answer is a fraction. That is my answer. So I have x equals minus 2/3 and y equals minus 2. Now, if I have time at the end of the paper, so say if time at the end, I'm going to check my answer by substituting both those values into the second equation. So check with second equation, just so I know that I'm right. Okay, let's move on. Okay, next question. The table shows some information about the dress sizes of 25 women. Okay, and it tells me to find the median dress size. So I know that the median is the middle number. Now, actually, I think finding median from a table is actually a little bit tricky. So I'm going to explain the long way of doing it, and then maybe you can see the shortcut. So the long way of doing it is just listing out all of the data that I've got. So if I look at the first row of my table, it says dress size 8, number of women 2. So what does that mean? Well, that means that 2 women have a dress size of 8. So I'm actually going to write out 8 and 8. Those are my first 2 pieces of data. 2 women have a dress size of 8. And then the next line, dress size 10, number of women 9. So what does that mean? Well, again, it means that 9 women have a dress size of 10. So I'm going to write out dress size of 10 9 times. 1, 2, 4, 5, 6, 7, 8, 9. And I'm going to do the same thing with dress size of 12. I'm going to write that out 8 times. 1, 2, 3, 4, 6, 7, 8. And finally, I'm going to write out 14 6 times. And now I'm going to cross off the biggest and the smallest until I get to the middle number. So smallest, biggest, keep on going. And I get 12, which is my median. That's the long way. You could do it a bit of a shorter way. You could say, okay, there's 25 pieces of data here. So to find the median, I'm going to do 25 plus 1 over 2, which is 13. That's just a method. You add 1 to the number of pieces of data and then divide by 2. And you say, okay, where does the 13th piece of data sit? Well, it doesn't sit in the first row. There's only 2. And then it doesn't sit in the second row, because that goes up to 11 only. And so the 13th piece of data is going to be in that third row, so it's going to be 12. And then part B is a bit of a funny one. It says 3 of the 25 women have a shoe size of 7. And then Zoe says that if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9/25. Is she correct? Well, I know that when when I'm choosing one piece of data or another, I do add the probabilities, which is what I've got here. But I don't think that in this case is right. And the reason is, if you think about it, if you think about the women here, they could have both a shoe size of 7 and a dress size of 14. So if you add them, then you're double counting a woman that has both of those things. So I'm going to say no. A woman might have both a shoe size of 7 and a dress size of 14. So quite a tricky 2-marker there early on, but let's move on. Okay, Daniel bakes 420 cakes. He bakes vanilla cakes, banana cakes, lemon cakes, and chocolate cakes. Okay, so I'm just going to put letters underneath. These are all my types of cakes. And it says 2/7 of the cakes are vanilla cakes. So I'm going to write vanilla, or V. I'm going to straight away do 2/7 of, so times 420. Put that into your calculator and you're going to get 120. Okay, take that off. I've worked out how many vanilla cakes there are. 35% of the cakes are banana cakes. Okay, so banana cakes, 35%. So 35% is 0.35 of 420, because it's still the total number of cakes. Put that in your calculator, you get 147. Then it says the ratio of the number of lemon cakes to the number of chocolate cakes is 4:5. Well, I need to work out, I think, how many lemon cakes and chocolate cakes I've got. So let's just write what I've know so far. So I knew that vanilla was 120, banana was 147, and all together there are 420 cakes. So if I add 120 and 147, I get 267, and then subtract that from 420, and I get 153, 153. So now I need to share lemon and chocolate in the ratio of 4:5. So let's just use a bar model for this. So nice big bar model. 1, 2, 3, 4. This is lemon. And then 1, 2, 3, 4, 5 for chocolate. And I know that there's 153 in total. So to find out what each part is worth, I can do 153 divided by, well, I've got 9 parts in total, and that gets me 17. So let's write 17 in all the bars. And it wants the number of lemon cakes that he has. So lemon is going to be 17 times by 4, which is 68. So I can write in my answer line 68. Let's keep going. Okay, in the diagram, AB, BC, and CD are 3 sides of a regular polygon P. Okay, regular polygon P. If I've got a regular polygon, that means that all the sides and the angles are equal, are the same. Okay, so let's have a look at a picture. I've got a square. So if I got a square, I think I can put on some right angles here. 2 squares. And I've got a regular 12-sided polygon, And it says, show that polygon P is a hexagon. Well, let's just remember that a hexagon has got 6 sides. Okay, so to work this out, I think that I need to find this angle here in polygon P. If I can do that, I can show that it's a hexagon. And I think my first step is going to be to actually find out what this angle is here, the angle in the regular 12-sided polygon. So step 1, I'm going to find out that angle. And if it's got 12 sides, let's just remember the steps. So I'm going to do 12 minus 2, which is 10. then multiply that by 180, and then divide that by the number of sides that I have. So that angle there is 150 degrees. So let's mark that on, 150. And I know that a square, obviously it's got right angles, it's 90 degrees. So now I think I can work out, step 2, let's just change pen color here, what this blue angle is here. And I've got angles around a point, which I know sum to 360. So I'm going to do 90 plus 150, which is 240, and then 360 minus that, which is 120. So I know that this angle here, this blue angle in polygon P, is 120. So now my final step is I need to somehow show that it's a hexagon. So I know that a hexagon has got 6 sides. So if I can show what the angle is, and it's 120, then I know I've shown it's a hexagon. So I'm going to do the same thing I did for step 1, which was 6 minus 2, which is 4, times that by 180, and then divide that by how many sides I've got, which is 6, and you do get that it's 120. So probably need a conclusion. Therefore, polygon P is a hexagon. Okay, great. Let's keep going. Okay, lots of words in this question. It's talking about the density of apple juice, density of fruit syrup, density of carbonated water. So I'm told the density of all 3 of these liquids, and I'm also told the volume. So it tells me the density, it tells me the volume, and it tells me to work out the density of the drink. So immediately when I see density, I'm going to draw out my density triangle. And obviously I know that M is at the top because Mr. Miller is on top and Miss Davies at the bottom. Don't tell Miss Davies that joke, please. Okay, so let's now lay out the table that I've got. So whenever I've got these multi-step density problems, I love laying out my working out in a table. So for my rows, I'm going to do my different types of drinks. So apple juice, I've got fruit syrup, so fruit syrup FS, and then carbonated water CW. So let's put down the things that I know. So I know the density, I've got the volume, and I'm not told any masses, but I'm going to be able to work them out in the question. Okay, so let's write down what I've got. Density of apple juice, 0.5, fruit syrup, 1.4, carbonated water, 0.99. Volume, apple is 25, fruit syrup is 15, carbonated water is 280, and I definitely want the total drink. That's going to be really important. So the total drink, well, I can add up the volume, which is 320, even tells me in the question, but I cannot add up the density. So in order to proceed, I think I need to work out the mass. And using my triangle, I know that mass is density times volume. So let's work out the mass for each of these 3 drinks. So the first one is going to be 1.05 times 25. And I should just write out my working so that I get the credit for it. So that is 26.25. The next one, 21. And then the final one, 277.2. Now I can also add up the masses. So if I add up all of the masses, 26.25 plus 21 plus 277.2, I get 324.45. Now to work out the total density, let's just write the equation for density. So cover up D, and I have mass over volume. So I'm going to take my mass, which is 324.45, divide it by my volume, which is 320. And it wants it to 2 decimal places, so 1.01 to 2 decimal places. So actually, pretty straightforward question, as long as you lay out your working carefully in a table. Let's keep going. Question 7. Okay, I've got a right angled triangle. So I know it's either going to be probably Pythagoras or SOHCAHTOA. Okay, calculate the length of AB. Let's mark on that length AB. Let's call it X. And because I've got an angle, I think I'm going to be using SOHCAHTOA. SOHCAHTOA. It's not Pythagoras because I've got an angle and I've only got one side length. So I need to figure out which of these to use. So to do that, let's mark on my sides. So opposite my right angle is always my hypotenuse. Opposite the angle that I've been given is always the opposite, and this one is the final one, which is the adjacent one. So let's circle the two sides I'm interested. So I've got 15, the hypotenuse, and I've got x, which is the opposite. So I think I'm going to be using SOH. Let's write that out. Sine theta equals O over H. And then my angle is 23. And then I need to solve this equation. Always going to multiply by my denominator. So 5 sine 23 equals x, which in the calculator, 3 significant figures, 5.86. Next question. Okay. A square with side length x is inside a circle. Each vertex, so corner of the square, the vertex is a corner of the square, is on the circumference of the circle. The area of the circle is 49. Now, this looks a bit confusing, but I think that if I draw a picture, it's going to be a lot easier. So let's draw a square, and it's inside a circle. So I'm going to put the circle on the outside. So let's try drawing a circle so that the corners of the square are just touching the circle. Not too bad of a drawing. And I'm told that the side length of the square is x. So I'll put x on as the side length. Okay, it then says the area of a circle is 49. So area of a circle, I know that the formula of area of a circle is pi times r squared. So I think it might be quite helpful to draw in a radius. So there is the center, and then I think a nice radius to draw on would probably be this one here. And let's also draw in the other ones. I think this is going to be helpful, and let's call all of these R. Okay, what have I got now? Well, actually, what I've got is I've actually formed all of these right angles in the circle, which might come in, will definitely come in handy later on. So I think if I know the area of a circle, I can find the radius by setting up an equation. So step 1, I'm going to find the radius. So I know that pi r squared equals 49. So I can find the radius by, first of all, dividing by pi. R squared equals 49 over pi. And then square rooting both sides. So square root of 49 over pi. So I know the radius. Now, step 2, well, because of the right angle that I formed, I've actually got a right angled triangle. I'm just going to draw out this right angled triangle. Let's draw that out separately. So it looks like something like this, where I know my radius, and it might be useful to just, let's see what the value of that is in the calculator. So the value of the calculator is 3.949327. I'm going to use lots of decimal places so that my answer is accurate. So let's put those radii on. And x, which is my hypotenuse. Now, I think that to find my value of x, I'm going to use Pythagoras. So let's do that now. This is A, this is B, and this is C. I'm going to write down Pythagoras' theorem. And then substitute what I know. So 3.9437 squared, running out of space, x squared. Now, actually, if you square both of those numbers, you should actually get 49 over pi. In my calculator, it's given me 15.59718. And then if we add those numbers together, we're going to get 31.194369 equals x squared. And then square root that finally, square root that, and you get 5.58519. So to three different figures, I think it's going to be 5.59, and I should put a unit in. Value of x, well, unit is centimeters. So actually, it all became a lot easier once I drew a picture. I definitely would have been very confused without a picture. So let's keep on going. Okay, question 9 is a box plot question. So the box plot shows information about the distribution of amounts of money spent by some male students on their holidays. And I can see I've got some space there, so I might have to draw a second box plot later on. Part A, interquartile range. Okay, so interquartile range is my upper quartile minus my lower quartile. I've been doing lots of this in school recently, so it should be okay. So here is my upper quartile, here is my lower quartile, and I have to look quite carefully at the graph. So there's in between, let's say 300 and 400, there's 5 gaps. So I think each gap is 20. So I think that my upper quartile is 300, 320, and it's in between 320 and 340. So I think that's 330. So a bit tricky here with the key, but not too bad. And then my lower quartile, well, that's 100, 120, 140, I think it's 150. It's actually, if you look at it, exactly halfway between 100 and 200. So let's just show my working out here. 330 minus 150, which gets me 180. So that is my interquartile range. Part B, the table shows information about distribution of amount spent by some female students. Okay, so draw a box plot for this information. So I'm going to write female students. And I'm going to plot this on. So I should be using a ruler here. So when you do this, make sure you use a ruler. So I think smallest is 60. That goes here. Lower quartile 180. Median 300. Upper quartile 350. Largest 650. Largest 650. And now I just need to connect them to make a nice box plot like that. Okay, part C. Chris says the box plot shows that female students spent more money than male students. Okay, so when it's talking about more or something larger, it is always talking about the median. So I'm going to refer to the median in my answer. So looking at the median, it looks like the median is larger for female. So I'm going to say yes, he is correct, as the median for girls, for female students, is higher. And just to be safe, I'm going to put in my data. So it is 300 versus, what was it, for male students versus 250 for male students. Next question. Okay, next question. So Naivy invests 6,000 for 5 years. Compound interest, so 5 years, underline that, compound interest of X. Okay, so I don't know what the percentage increase or the interest rate is, but I do know what it was at the end. So let's just set up my scale factor model. So my original and my new, 6,000 and that thing there. And I know that I'm multiplying by something. Let's actually call that y. I'm going to call that y, not x, because x is actually the interest rate. So let's call it y, and then I'm going to figure out the interest rate from my scale factor. But it's y to the power of 5, because it's 5 years. So it looks like I'm going to need to set up an equation. So 6,000 times y to the 5 equals this thing here. So I need to find my value of y. Well, first step, let's divide by 6,000. And I get y to the power of 5 equals, well, when I do that in my calculator, I get 1.336225. And write out all the decimal places. Now I'm going to, on both sides, find the fifth root. And you need to know where in your calculator you do this. So in my calculator, I need to put the shift and then the sort of x to the power of something button. So you need to know where that is on your calculator. You do that and you get 1.059999. So very, very close. I'm just going to write 1.06 to 3 significant figures. Now, what does that mean the interest rate is? Well, if you think about what 1.06 is, what percentage increase is that? Well, I think that is a 6% increase. And I know that because 100% plus 6% is 106%, which divide that by 100, you do get 1.06. So I figured out my percentage increase from my scale factor 1.06. So that's my answer, x equals 6%. Let's move on. That was a little bit of a tricky one. Let's move on. Okay, question 11. Jeff is choosing a shrub and a rose tree for his garden. So I think this is probably going to be a combination type question. So 17 different types of shrubs and some rose trees. So I don't know how many rose trees there are. Let's call that X. So he says there are 215 different ways to choose one shrub and one rose tree. Is he correct? Okay, so I know that when I'm doing my counting, it's called the product rule for counting. So I'm going to multiply together 17 times by x, and then I'm going to see what x is. Now, if x is a whole number, then that is how many rose trees there are. But if x isn't, and if you do 215 divide by 17, you get 12.6. So you don't get a whole number. So we can't have 12.6 row trees. It has to be a whole number. So I'm going to say no, since 12.6 is not a whole number. And that's it. Let's keep going. Okay, next question. The points A, B, C, and D lie in order on a straight line. Okay, it's given me some ratios here, and it's asked me to work out AB to BC to CD. Now, I'm looking at this question, I'm thinking, what on earth is going on here? But actually, I think that if I actually draw out these points on a straight line and put the ratios on, it's going to be a lot easier to solve. Just like it was for question 8 when I drew a picture. So let's draw a line here. And it says that they lie in order on a straight line. So that means it's A, then B, then C, then D. So let's put A at the start. Let's put D at the end. And then AB to BD is 1 to 5. So if I think about where B goes, somewhere about there. And then AC to CD is 7 to 11. So I think C is probably about there. Okay, let's put this all on now. So AB to BD. So A to B is 1, and B to D is 5. So B to D is 5. And then A to C, that is 7. And C to D is 11. Now, what do I notice here? Well, I notice that if I look at the total from A to D, well, at the top, the total is 7 plus 11, which is 18. And at the bottom, the total is 6. And obviously, the distance has to be the same. So I need to think, what am I going to do to make the distances the same? Well, I think we're going to have to multiply all the ratios on the bottom by 3, because 6 times by 3 gives me 18. So if I multiply the 1 by 3, that gets 3, and then 5 times 3 is 15. So I'm actually just going to use a different color pen. So 1 to 5, that is the same as 3 to 15. So I haven't changed the ratio is the same, but what I've now done is I've made the distance from A to D the same in both, which is 18. So now let's look at AB. So I'll put AB, BC, and CD. Well, what is A to B? A to B is 3. But what about B to C? Let's just draw that on. B to C. Well, I can see that A to C is 7. And A to B is 3. So that must mean that B to C is 4. So B to C is 4. And then C to D, I can see is 11. And I'm done. So actually, that wasn't too difficult at all once I'd drawn my picture and once I'd realized that the total distance has to be the same in both. So let's keep going. Okay, question 13. Write down the 3 inequalities that define the shaded region. So we haven't actually done this much in class. So I'm going to go through the question. I put a core book reference 182 if you want to try more, and then we will look at this as part of our revision lessons. So what I actually need to do, the 3 inequalities, I need to write down the equations of the graph and then figure out where the inequality sign go. So I can see that I got 3 lines. I've got line 1. I have got, let's call this one line 2, and this one line 3. So my first step is to figure out the equation of these lines. So first of all, equation 1. Well, I can see that it's a horizontal line. So I know it's x equals something or y equals something. And to do that, let's find out some coordinates. So this coordinate here is 4 minus 2. This one here is 6 minus 2. So what's the same in both? The same in both is that y equals minus 2. And I'll deal with the inequality later on. Let's do equation 2. So equation 2, well, the first thing I need to do is work out the gradient. So let's pick 2 points. Let's pick this point here and this point here. And to find the gradient, I need to do the gradient is equal to, so line 2, gradient is equal to change in y over change in x. Change in y is 2, change in x is 2, so that gradient is 1. And the y-intercept, well, let's circle the y-intercept, it is just 0. So if I've got the equation of that straight line, y equals mx plus c, well, I said that m was equal to 1, so it's just 1x, and c was equal to 0, or I can just rewrite that as y equals x. Okay, same thing with 3, so let's change pen color with 3. Let's pick 2 points. Let's pick this one here and this one here. So this is 3. So my gradient, change in y over change in x. My change in y here goes from 2 to 1, which is just 1. And my change in x is 2. So my gradient is 1 over 2. And my y-intercept, let's circle that, is 1. So y equals mx plus c. Y equals a half x plus 1. Okay, now my final step is I need to write these as inequalities. And the thing to remember here is that if the shaded region, let's write this down, if shaded region is above the line, you're going to write greater than or equal to. But if it's below, you're going to write less than. And I know which one I'm going to write, because if it is a solid line, you're going to write bigger than or equal to, or less than or equal to. And then if it's dotted, it's one of those two. And all 3 of my lines are solid, so I'm going to write greater than or equal to, or less than or equal to. So let's have a look first of all at equation 1. Now equation 1, what was that? We said that was y equals minus 2. And if you look at the shaded region, it is above that line. I can see that the shaded region is above that line, so I'm going to use greater than. So y is greater than or equal to minus 2. Equation 2, that was y equals x. Well, if you have a look at the shaded region, I think the shaded region is, again, above that line. So I'm going to use y is greater than or equal to x. And then finally, with equation 3, if you have a look at that line, I can see that the shaded region is below that line. So this time, I'm going to use less than or equal to a half x plus 1. So just to recap the step, my first step was to find the equation of my line. And then my second step was to figure out what inequality sign I needed. Put it all together, and I got the 3 inequalities that define my region. Next question. Okay, so this is an algebraic fraction, and I'm going to simplify it. And I know that when I see these types of questions, my key is to factorize. So first, x squared minus 16. That is, of course, difference of 2 squares. So x plus 4, x minus 4. Now, the second one, let's write that out. 2x squared minus 5x minus 12. This is a quadratic. Let's factorize this. I want two numbers that multiply. Remember, if my coefficient in front of the x squared is more than 1, I need to multiply 2 times by minus 12, which is minus 24, and add to make minus 5. So what are those numbers? If I'm not sure, I can list out the factor pairs of 24. So 1 and 24, 2 and 12, 3 and 8. Well, I think it's going to be 3 and 8 because the difference is 5. So what is it going to be? Well, which one's negative? I think it's going to be minus 8 and 3 because minus 8 plus 3 equals minus 5. Okay, so my next step is to rewrite this, but split up my x term. So let's just change color for this. So my 2x squared stays the same, and I'm going to split this minus 5x up into minus 8x and plus 3x, keep the minus 12 the same. So really important that you're confident in factorizing these types of quadratics. Now I'm going to do my technique that I've shown you, factorize the first bit. So what goes into 2x squared and minus 8x? So I think it's 2x, x minus 4, plus 3 brackets x minus 4. And I'm happy when I see that I've got x minus 4 in both brackets because it means that I'm correct. And my final step is to do x minus 4, and then this 2x plus 3. And I'm done. Okay, final step. Let's rewrite my function. So on the numerator, I've got x plus 4, x minus 4, and the denominator, x minus 4, 2x plus 3. And when I see these types of questions, I'm always expecting to be able to cancel. So I can cancel here because my x minus 4 is the same. If you work out something and you can't cancel out, you've probably gone wrong. So my final answer is going to be x plus 4 over 2x plus 3. Okay, next question, almost there. Okay, part B of this question, make V the subject of the formula. Okay, so V the subject means my answer needs to look like V equals. And it's a good opportunity to practice this on Corbett if you weren't sure on this one. So let's go through it. My first step, I see I've got something in the denominator, so I'm going to get rid of that denominator by multiplying by it. So W times V is WV equals 15t minus 2v. Now I see some brackets here, so I'm going to multiply out the brackets. 15t minus 30v. Now let's highlight the terms that have v in them. So this one's got a v in it, and this term's got a v in it, and I need to move all those terms onto one side. So let's add 30v onto both sides. So VW plus 30V equals 15t. And then I'm going to factorize out the V. So V, open brackets, W plus 30. And then final step, I'm going to divide by what's inside the brackets on both sides. So I can write that straight onto my answer line. V equals 15t over W plus 30. Okay, next question. I can see a triangle, and it tells me that the area of triangle ABC is 6 root 2. Okay, interesting. Area of a triangle. So straight away, area of a triangle, I can see that I've got the two sides and an angle in between. So straight away, I'm going to write down my formula for area of a triangle? Half AB sine theta. So I think that the first thing I'm going to write down is an equation connecting all of the information. So let's call this side A, this side B. Doesn't matter which way around we put A and B. And this angle 45 is theta. So let's write down the area, which is a half A B sine 45 equals 6 root 2. And now let's find out what sine 45 is. So sine 45, let's rewrite this. Sine 45 is equal to root 2 over 2 equals 6 root 2. So I actually think if I have a look at what's in brackets here, if I just highlight what's in brackets here, and also let's highlight the fact it's worth 5 marks, it looks like this is going to be a quadratic equation that I'm going to need to solve. So before I do anything, let's get rid of my denominator. So if I have a look at the half, and I multiply that by root 2 over 2, that is root 2 over 4. So I'm going to rewrite this as root 2 over 4, then bracket 2x minus 1, x plus 3 equals 6 root 2. And now I've got 4 in the denominator, so let's get rid of that. I'm going to multiply by 4 on both sides. So I've got root 2, 2x minus 1, x plus 3, and 6 times 4, so 24 root 2. And let's now get rid of the root 2's, which will actually cancel out. So I'm not going to have any more square roots, which is a good thing. So I'm going to have 2x minus 1, x plus 3 equals 24. Now I know with quadratic equations, I need to get 0 onto one side. So before I do that, let's now multiply out these brackets here. So I'll do my working to the side. So I've got 2x minus 1 times by x plus 3. So let's do that working here. That's going to give me 2x squared plus 5x minus 3. So 2x squared plus 5x minus 3 equals 24. And now, to get 0 on one side, I can minus 24. Minus 24. So I've got 2x squared plus 5x minus 27. Now, it looks like I could factorize this, but I actually don't think that I can't. And the reason why is because the answer says give it to 3 significant figures. So I know I can't factorize. So what other way do I know to solve a quadratic equation? Well, I know the quadratic formula. So I'm going to use a quadratic formula. Let's just write that down what it is. So it's x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's write down what my a, b, and c are. A is 2, b is 5, and c is minus 27. So let's put that into the quadratic formula. I've got x equals minus b, so minus 5, plus or minus the square root of b squared minus 4 times by 2 times by minus 27, and that's all over 2 times by 2. Okay, so I can put that straight into my calculator, or I can tidy it up a bit. X equals minus 5 plus or minus. Now, inside the bracket, I've got square root of 241, and that's all over 4. And if you put these values into your calculator, you have the first one being 2.63, and the second one being minus 5.13. And which one of those is it? Well, my length can't be negative, so it can't be x2. So I'm going to tick this one, and I'm going to put a box around it. X equals 2.63. So it wasn't actually too bad once I got rid of my my half and my square root signs. It just turned into a normal quadratic equation that I could solve. So let's move on to our next question. Okay, next question. So question 16, this looks straight away like an iteration question. Now actually, you should have been able to do part A. We did that last year, but I haven't taught you yet how to do part B. So I'm going to go through it, but we will go through it in class, so don't worry. Part A, well, you're just going to use the iteration formula, starting off with x0 equals minus 2.5. So in your calculator, to find the next value, x1, we're going to do minus 2 minus 4 over xn squared. So that's our starting value. So that is minus 2.5 squared. And if you put that into your calculator, you get minus 2.64. And then if you do that again, so you do x2, now actually there's a quick way to do this, which is if you have your previous answer, so minus 2.64, as your answer in your calculator, all you can do is put minus 2 minus 4 over ants squared. And that's going to give you your next value, which is minus 2.5739. And if you just press equals again, it will give you your next one. x3 equals minus 2 minus 4 over answer squared. And that gives you x3. So I can write those values on my answer line. So minus 2.64. And I can write down my other values. Okay, so part B, it says explain the relationship between the values of x1, x2, and x3 and the equation x cubed plus 2x squared plus 4 equals 0. Now, actually, one of the uses of iteration is that it can actually help us solve different equations. And the reason why is let's start off with the starting formula. So x n plus 1 equals minus 2 minus 4 over xn squared. Well, if I just call both of the x's just x, so let's call it x equals minus 2 minus 4 over x squared. Now, if I rearrange this formula by multiplying everything by x squared, I'm going to have x cubed equals minus 2x squared minus 4. And then if I bring the 2x squared, or the minus 2x, and the minus 4, so if I add those to both sides, what you actually get is the equation that we've been given in the question. So that is the same as the equation in this question. So it turns out that using this iteration formula actually gives you the answers or an approximation to that equation. So that's what I'm going to write down. I'm going to say, first of all, that x cubed plus 2x squared plus 4 equals 0 is a rearrangement of the iteration formula. Therefore, x1, x2, and x3 are estimates of the solution of this equation. And that's what you would need to write down to get those 2 marks. So don't worry too much about this. We will cover this in class, but this is what you would need to say for this question here. Let's move on to the next one. Okay, question 17. So we got a train traveled along a track in 110 minutes. Correct to the nearest 5 minutes. Okay. So straight away I am thinking, if it says correct to the nearest 5 minutes, this is definitely going to be a bounds question. Jake finds out that the track is 270 kilometers long Okay, so that is a distance. I've also got a time. And then it's telling me in part A, could the average speed have been greater than 160 kilometers per hour? So I think this is actually a combination of a bounds question and a distance, speed, time question. So let's draw my distance, speed, time triangle. So I need to use that later. And now I'm going to draw in the bounds. So the first bound is my time of 110 minutes. So let's draw out that number line. Put 110 minutes in the middle. Increase that by 5 to get 115 and decrease it by 5. And you're going to put your numbers in the middle. So that is my lower bound and upper bound for time. And it's worth saying that this is in minutes. And then we'll do the same thing for our distance, which is in kilometers. So number line again. We'll put 270 kilometers in the middle. And then we are going to go up 10, down 10, and then put the 2 times in the middle. So we're saying, could the average speed of the train have been greater than 160? So I want to find out speed. And so the equation of speed equals distance over time. And it says greater than. So I think if I find the upper bound, the maximum, we could see, could it have been greater than 160? So what distance and time do I want? Well, I think I want my highest distance, so that is 275 kilometers, over my smallest time, which is 107.5 minutes. And that's going to be my answer. But hang on a second, because my average speed is in kilometers per hour. And that's a problem because the speed that I've got is in minutes. So what I think I'm going to have to do is convert 107.5 minutes into hours. Okay, so to do this, let's break down 107.5 minutes. So I know that there's 60 minutes in an hour. So this is 1 hour. So 60 minutes, which is 1 hour, plus how many minutes left? Well, 107.5 minus 60 is 47.5 minutes. So I actually need to convert this 47.5 minutes into hours. Well, how do I do that? Well, I'm always going to divide by 60 to give my fraction in terms of hours. If you do that, you're going to get 1, which is my 1 hour, and then this is 19 over 24 as a fraction. So 1 and 19 over 24 hours. So now I'm ready to work out my maximum possible speed. So maximum speed, well, 275 kilometers over 1 and 19 over 24 hours. And if you pop that into your calculator, you get 153.4 kilometers per hour. So what's our conclusion? That is our maximum possible speed. Could it have been greater than 160? Well, my answer is no, it couldn't have been greater. And the reason is that this number that I've got is less than 160. So that's what I would need to say. Okay, part B. Jake's assumption was wrong. The track was actually measured correct the nearest 5 kilometers. Explain how this could affect your decision in part A. So when I get these questions, I'm thinking, what has changed? What has changed? Well, if the distance was measured to nearest 5 kilometers, let's just draw on this distance thing again for part B. So I would still have 270, but the maximum, if I put 275 at the top, 265 at the bottom, and put these times in the middle, Well, actually, the distance I would have used would have been 272.5. So the speed would have been 272.5 over 1 and 19 over 24. But actually, if you think about that, because the numerator is smaller, the answer would have been smaller. So we would have said it wouldn't have affected the answer. And why? Because the answer would have been smaller. Because the greatest possible distance would have been smaller. So that's what I would need to say. Let's go to the next question. Okay, question 18. Looks like I have got a possibly a circle theorem question here, but let's have a look. So A, B, and C are points in the circle of radius 5. Okay, I've got that radius 5 on the diagram, center O. Now DA and DC are tangents to the circle. Now, as soon as I see tangents, I know that a tangent to a circle, or tangent to a radius, is a right angle. And I've got a radius, I've got a tangent, so let's mark on my right angles here and here. Work out the length of arc ABC. Arc ABC. Okay, so let's get my highlighter and let's highlight the length that I want to find out, which is this length here. Okay, DO equals 9. DO equals 9. So let's put that in the question because that's not in the question. Now I know to work out the length of arc ABC, I need to find my angle. I need to find my angle here. And the angle that I think I can find is this angle. Let's call it theta. But I also think if I have a look at this diagram, I think it's also the same as this angle here. So I know I can work out that angle because I've got an unknown angle and two sides. So I'm going to use SOHCAHTOA to find that angle. So let's mark on these sides. Let's do that. This is the adjacent 5. This is the hypotenuse, and this is the opposite. So if I circle A and H, I'm going to use cap. So my first step is to find out theta. Cos theta equals A over H, which equals 5 over 9. So in my calculator, I'm going to do cos inverse 5 over 9, which gets me 56.251. So let's put those in. 56.251, 56.251. Now to find the arc length, there's actually a couple ways you could do it. But what I'm going to do is I'm going to find out this green angle here and then use that, because that green angle is the fraction of the circle that my highlighted arc is in. So I'm going to find out this green angle. So I'm going to do 360. Let's call this angle alpha. I'm going to do alpha 360 minus theta, because angles around a point sum to 360. Put that into a calculator, you get 247.498. 247.498. So therefore my final step is now I can work out my arc length, because the fraction of the circle that I've got now is my angle over 360 times pi times by my diameter. And what's my diameter? Well, it is 10. That's my diameter. And I knew it was 10 because it's 5 times by 2. The radius is 5, so double that. And then all you need to do is put that into your calculator. 3 significant figures. 21.6 centimeters. Okay, let's go to the next question. Okay, 2 more to do. It's a solve, and this is a quadratic because I've got x squared here, and it's a quadratic inequality. So quadratic inequality. That's my type of question. And I put a Corbett reference 378 for you to practice these. So I know that for quadratic inequalities, I first need to factorize. Then I'm going to plot a graph, and then I'm going to work out my answers. So my first step is to factorize. So I want two numbers that multiply to make 2 times minus 2, which is minus 4, and add to make 3. So what are those two numbers? I think they are minus 1 and 4. So I'm going to rewrite this as 2x squared minus 1x plus 4x minus 2. We've seen this a couple times in this exam series. And now factorize. So x, open brackets, 2x minus 1 plus 2x minus 1. It's bigger than 0. Good news, I've got 2x minus 1. So 2x minus 1, x plus 2 is bigger than 0. So if I wanted to solve this equation, I would want both of these brackets to equal 0. So this one here is easy. x2 equals minus 2. But this one here, I want 2x minus 1 to equal 0. And I'm going to solve it now. So I get x1 equals a half. So let's now plot this graph here. So I got minus 2 and a half. And my quadratic looks like that. Okay, so my final step is to figure out what part of the inequality I want. So because it's bigger than 0, remember, I need to have everything that is above my x-axis. So how do I write this region? Well, this first region here, x is bigger than a half. And then this here, x is smaller than minus 2. So let's write that down. X is bigger than a half, or x is smaller than minus 2. So quite a nice question, question 19, as long as you're happy with factorizing a quadratic and then working out which region to choose. And I always suggest that you draw a graph so that you don't get confused. One more question to go. Let's have a look. So question 20, the equation of a curve is y equals a to the power of x. A is the point where the curve intersects the y-axis. Okay, interesting. Intersects the y-axis. So it's a bit of a weird question. Now, if you actually know what this kind of graph looks like, this is called an exponential graph. We had it in paper 2. We're going to cover it in class soon, but this graph actually looks like this. Now, you don't need to know this because it doesn't matter what this graph looks like. Let's just draw a random graph here. Let's draw a random graph. I don't know, something like that. Now, if it intersects the y-axis, so this point here, well, what do you know is true at that point? Well, what's true at that point is that your x-coordinate equals 0. So if I take my equation, y equals a to the power of x, and I say, okay, at this point here, x equals 0, I've got y equals a to the power of 0. Now, anything to the power of 0, remember, is always equal to 1. We learned that when we did indices. Anything to the power of 0 always equals 1. So if x is 0 and y is 1, then my answer is 0 and 1. Bit of a weird one for 1 mark, but intersects the y-axis was your big clue there. Part B. The equation of a circle is x squared plus y squared equals 16. So we did equations of circles fairly recently. So remember, this is actually r squared. So if r squared equals 16, then my radius is 4. Now, the circle C is translated by the vector 3, 0. Now, translated by the vector 3, 0, Well, that 3 means 3 to the right and 0 up or down to give circle B. Draw a sketch of circle B. Okay, so it's telling me to draw a sketch. Let's draw a sketch. So I'll do that here. So first of all, let's draw circle C. So that's a circle at the origin. So this is circle C. And let's label on my point. So this is 4, this is 4, this is -4, and this is -4. Now, if it's going 3 to the right, let's think about what happens. Well, where does this 4 go to if it goes 3 to the right? Yeah, I think it's going to go to 7. I think it's going to go to 7. What about this -4? If it goes 3 to the right, well, I think it's going to go to -1. So let's sketch this circle now. So sketch the circle. It's going to look something like this. And then it says, label with coordinates the center of circle B. Okay, so where is this center going to be? Well, before, the center was at 0, 0. And if it goes 3 to the right, then I think my center is going to be at 3, 0. So this is my center. And any points of intersection with the x-axis, well, I found them already. So let's just call this first point 7, 0, because I want the coordinates. And this one is -1, 0. And that is it. I'm done with that paper. Thanks very much for watching, if you watched the whole thing or even just certain questions. Hope it was helpful. And I'll be uploading paper 1 of 2018 soon. Thanks very much. Bye-bye.